Good evening and welcome to my group's final Lab 13 presentation. Today we chose to do the Jack in the Box. I'm Jabari.
I'm Isaac.
And I'm Jordan.
Let's get into it. So, a brief history of the machine. In the early 1500s, the first Jack in the Box was made by a German clockmaker known as Claus as a gift for the son of a local prince. It is a children's toy that outwardly consists of a box with a crank. And when the crank is turned, a music box mechanism in the toy plays a melody. And after it has been turned for a sufficient number of times, the lid pops open and a figure, usually a clown or jester, pops out of the box. Some jacks in box open at random times when cranked, making the startle even more effective. The purpose is simple. In modern days, it's used as a toy for children's enjoyment due to the surprise factor associated with it. Back in the day, it became frequently used as an image in political cartoons featuring the face of the latest politician, where they would usually make fun of them. And last but not least, of course, just to have fun.
So the mechanical advantage of the Jack in the Box, the input is the compressed spring with the lid. So as you close the lid, a latch covers the top, and that is holding the lid down while the spring is pushing back up on the lid of the box. And the output, when the crank is turned and it is turned enough times, the latch is released, allowing the uh, spring to push open the lid and launch the gesture out the top and have it bounce around. For the ideal spring, the mechanical advantage is equal to 1, but in realistic conditions, due to frictional losses, especially having a big sock puppet over the spring, it's definitely going to be less than 1. Uh, also, the gear ratio of the crank and the music box is 14-1. The system diagram is right here, where you have a crank that's turned, which turns a spur gear, uh, it turns a worm gear, and that in turn turns the spur gear, which turns the music box. And when that is rotated enough, a little lever comes around and hits the release lever, and that release lever is being held in torsion by a torsion spring. And then along the sides are the fasteners, which it allows it to fasten on the inside, on the side of the box, where it can allow the lever to sit near the top and hold the lid closed. Here are the free body diagrams of each of the components. So on the right, the uh, we have the music box, the force of the music box, the force of the threads, and then the torque. That's just the fastener screw. In the middle, we have the spur and worm gear uh, pushing and pulling against each other. And then on the left side, we have the lever holding the lid of the box closed as the spring is pushing back up on the box. The lever is being held again by a torsion spring, holding it outwards, so it is wanting to stay on top of the lid and it doesn't release at a random time, but only when the cycle of the melody is played and the lever is released to open and show the clown.
First of our components was a spring with design so that it can withstand compression for a long period while also rotating its free length. Both springs are loaded by closing the lid where the little jack guy pops out. And when the release lever is triggered, the top of the box will be freed open so that the spring will push the puppet out of the box. And our next part is the gear. Like I said earlier, the gear ratio is a ratio of 14-1, where it takes 14 worm teeth to rotate through one spur tooth. And our gears do have minimal interference, so they do actually work. And they're used to turn the music box and the release lever. And then the lever releases once you have completed enough turns of the music box to release the lever. And our third component is the fastener. Fasteners were designed to withstand the vertical force from the music box pieces. We have a total of 5 screws. They are machine screws with a Phillips head made out of steel with threaded holes. They're coarse threads and with a high enough thread engagement to avoid stripping. So that way you don't break the entire music box by using it too much. And we decided that to improve on the design, we could increase the gear ratio, because increasing the gear ratio will mean that you can play through the melody faster, which means that you can make the jack pop out faster. So you could increase that surprise factor, that fun factor for whoever playing with it. And you could also the more you change the gear ratio, the more you change how fast until the melody is played. So we figured that if you increase the gear ratio, you can increase the mechanical advantage even further, which makes the toy even more fun. These are our references. Thank you. If you have any questions, please leave them in the chat. We'll try and answer them. Yeah. Feel free to like, comment, and subscribe.